Okay, so now that we've talked about multiplying rational expressions, let's talk about dividing. If you remember back in the day, there's an algorithm when we divide fractions that we actually don't divide fractions. We can multiply by its reciprocal. You can remember it as keep, change, flip, flip the guy and multiply, or just multiply by the reciprocal. So remember, if I had 2/3 divided by 1/3, I would keep the first fraction, I would change the division to multiplication, and then I would flip the second fraction, multiply by his reciprocal. And then now that I'm multiplying, I can just multiply across my numerators, multiply across my denominators, and then I can reduce if I need to. We could do the same thing with rational expressions. If I have two rational expressions, I can divide them by multiplying by the reciprocal. I keep the first one, I change the division to multiplication, and then I reciprocate the second fraction. So I flip it. And then if you notice that I'm multiplying, I can combine my numerators, I can combine my denominators, and if there's a factor of the top that can reduce with a factor of the bottom, well then I can reduce off the x plus 2's. I would have left over x minus 3 over x minus 2. We're going to do that same idea. Look at example number 2. We're going to divide and simplify. But remember, dividing fractions is the same as multiplying by the reciprocal. So I can keep the first fraction, change to multiplication, and flip the second fraction. Multiplying across my numerators, 4 times 9 is 36, and then I have an x squared and a y squared. On my denominator, 3y times 2x is really 6xy. I have a monomial on top and a monomial on bottom. I have one term on top and one term on bottom. I should be able to reduce the 36 and the 6. I should be able to reduce the x's, and I should be able to reduce the y's. Or I can divide by that GCF of a 6xy. Making sure that you divide the numerator and the denominator by that GCF. 36 divided by 6 is 6, x squared divided by x is x, and y squared divided by y is y. 6 divided by 6 is 1, x divided by x is 1, and y divided by y is also 1. So really on the denominator, I just have a 1. So I can say 6xy over 1, or I could just say 6xy as my final answer. Let's do another one. Look at B. B looks a little bit different because now I have a trinomial divided by a binomial, and then I have another rational expression with two binomials. But remember, dividing fractions is the same thing as multiplying by the reciprocal. So again, I can keep the first one, change to multiplication, and then flip the second one. And now I have multiplication. So like we did in the first video, I can factor the numerator, factor the denominator into different factors. The top numerator is a basic factor, the denominator is a difference of squares, and then I can put my numerators with my numerators and my denominators with my denominators as long as I'm multiplying. Now I can try to reduce by looking for common factors. I noticed that the numerator had an x plus 1 and the denominator had an x plus 1. It doesn't look like there's any other common factors, so it looks like my final answer has an x minus 3 and an x plus 5 on the top. On the bottom I have an x minus 2 and an x plus 2. That's as reduced as I can get it. All right, let's keep going. On C, I notice that I'm dividing, so instead I can change it to multiplying by the reciprocal. I'm going to go ahead and factor all of my pieces and write all of my numerators together and all of my denominators together. I noticed on the top left fraction, I can GCF out a 5, leaving me with an x minus 2. I also noticed on the bottom right fraction that I could GCF out a 4, leaving me with an x minus 2. My numerators now have a 5 times a 9, or really could I say 45? I also have an x squared, and I also have multiplied an x minus 2. So I have 1, 2, 3 factors on the top being multiplied. On my denominator, I have a 3 times 4, or a 12. I have an x, and I have an x minus 2. Now all of these pieces are just factors of, right? They're just being multiplied. They're not connected with plus or minus signs. And so what can I reduce out of the numerator and the denominator? What is my GCF? Well, it looks like in my coefficients, what number can divide into 45 and 12? It looks like I can divide both of those by 3. It also looks like I can take an x out of my x squared and my x, and it also looks like I can reduce the x minus 2 and the x minus 2. So then what do we have left? If I take the 45x squared and divide it by 3, 45 divided by 3 is 15, x squared divided by x is x, And then remember my x minus 2 reduced with my x minus 2 in the denominator. And then I'm going to make sure that I divide the 12x by 3. 12 divided by 3 is 4, and then x divided by x is 1. So 4 times 1 is 4. So on my top, I have left over a 15x. On the denominator, I have a 4. Can't be reduced anymore, so that looks like it's my final answer on that one. Keep going. Try D by yourself and see what you get. All right, dividing is the same as multiplying by the reciprocal. So I kept the first one as I factored the denominator into a difference of squares. I flipped the second fraction and I factored the new numerator into an x minus 1 and an x minus 1. That's a perfect square. If you combine the numerators and combine the factors of the denominator, if there's any common factor that I can reduce, it looks like I have an x minus 1 on the top and bottom. It looks like I have an x plus 1 on top and bottom. It looks like the leftover factors are an x minus 1 over x plus 1. Now they look close to being the same, but they're not exactly the same, so I can't reduce that factor of a common factor because they're not exactly the same. So I would just have to leave it x minus 1 over x plus 1. Again, you can write it without the parentheses if you'd like to. It means the same thing. Just be careful not to reduce the x's and the 1's because they're still connected binomials that can't be reduced because there's 4 different terms. And if you can't reduce a common factor out of all 4 terms, then you can't reduce. So you would just leave it like that. All right, let's do 2 more, and then I'll have you guys try some on your own. Looking at E, I'm still dividing, and technically I'm still dividing fractions. If you wanted to take this trinomial and write it as an x squared plus 9x plus 14 over 1, then it's dividing 2 fractions, right? And so dividing fractions means I can multiply by the reciprocal. I can keep my first fraction, and what I'm going to do is I'm going to keep it and factor it at the same time. It looks like the numerator and the denominator are both basic factors. Pause the video, factor it, and then come back to me and see if you got the same factors. I got x plus 7 and x plus 3. On the denominator, I got an x minus 5 and an x plus 3. All right, dividing fractions is the same thing as multiplying by the reciprocal. So when I reciprocate x squared plus 9 plus 14 over 1, it really turns into 1 over x squared plus 9x plus 14. And then I factored my new denominator into an x plus 7 and x plus 2. 7 and 2 multiply to 14 and add to give me 9. All right, now that I'm multiplying these 2 fractions, I know that when I'm multiplying, my numerators go with my numerators, my denominators multiply with my denominators, and I have one big old fraction with lots of factors in there. Let's see if I can reduce any. I notice that I have an x plus 1 on the top and bottom. I have an x plus 7 on the top and bottom. And so now that I've factored out or reduced off the x plus 7s and the x plus 3s, what's left in the numerator? There is still a numerator. Remember, there's just a 1 on the top now, so you need to make sure that you keep its place. So I have a 1 left on top. On bottom, I still have the x minus 5 and the x plus 2. So it looks like that's our final answer. All right, last one. Let's look at F. Kind of similar to E, it looks like I have a 5a squared plus 10a, and I could really say over 1. So now I'm looking at 2 fractions being divided, so I know that I could really multiply by the reciprocal. I'm going to keep the first fraction, but factor it. Now be careful. I can factor the top into an a plus 2 and a plus 1, but please do not factor that denominator. Don't let me get you. That's not a difference of squares. Remember, it has to be a subtraction sign in order to be able to divide, or not divide, but factor into a difference of squares. And since it's not a subtraction sign, I have to just keep it the way it is, okay? All right, I'm going to change it to a multiplication sign, and then I'm going to flip that second fraction and take out a GCF of a 5a, leaving me with an a plus 2. All right, it looks like I can put my numerators with numerators and denominators with denominators. I have a common factor of an a plus 2 in my numerator and in my denominator. It looks like my numerator has left a 1 and an a plus 1. My denominator has a 5a and an a squared plus 4. I can't reduce anything else. There's no common factor for all of my terms, so it looks like that's the final answer for that one. All right, we've done a lot of problems with multiplying and dividing fractions. Why don't you try these 2 division problems now before we move on to our homework and the next section. So pause the video, divide these two rational expressions for me, and then check back with me and see if you got the same answer. All right, on number 1, I kept the first fraction. I multiplied by the reciprocal. I put numerators with numerators and denominators with denominators. I ended up here with an x to the 5th y over x squared y to the 2nd. And then I reduced by a GCF of an x squared y. I can take an x squared y out of the numerator and an x squared y out of the denominator. That left me with an x cubed in the numerator and a single y in my denominator. I hope that you got the same thing I did. All right, try it number 2 is kind of a good one. There's lots of different factorings in this one. It looks like 2 basic factors and 2 bottoms up. All right, I kept the first rational expression, first fraction. I factored the numerator into an x minus 7, and I factored the denominator using my bottoms up. I did the work up at top. I multiplied, I factored, I divided by 2, I reduced, and I brought my bottoms up. That's how I got the factors of 2w minus 7 and w plus 2. All right, I changed the division into a multiplication, and then I flipped my second fraction. I multiplied by the reciprocal. That means my w squared minus 6w minus 16 went up to the numerator, and I factored that into a w minus 8, w plus 2. My 3w squared minus 20w minus 7 is a bottoms up factoring. That went down to my denominator, and I factored it using bottoms up. That's how I got the w minus 7 and the 3w plus 1. Now that I have a multiplication problem, I know that I can put my numerators with my numerators and my denominators with my denominators, and then I can reduce common factors. I see a w plus 2. I see a w minus 7. Oh, looks like that's the only common factors that I have left. So I have a w minus 7 times a w minus 8 in the top. I have a 2w minus 7 and a 3w plus 1 on the bottom. No other common factors. It looks like that's as simplified as it's going to get. Hopefully you got the same answer on that one also. That was a good one. All right, keep practicing.